Hello everyone, in this video I'll be solving the problem for fun permutation. So it was asked in Codeforces Round 1047 for division 3. So yeah, basically I have actually shooted this video, but I don't know, for some reason my audio quality was not good, so I just deleted it and then shooting it now. So it's 1:25 in the night. So yeah, let's shoot it one more time. So we're given a permutation P of size n. Okay, your task is to find a permutation Q of size n such that GCD of P of I plus Q of I, comma P of I plus 1, plus Q of I plus 1 should be greater than or equals to 3 for all I greater than or equals to 1 less than n. In other words, the greatest common divisor of the sum of any two adjacent positions should be at least 3. Okay, it can be showed that this is always possible. Okay, I think they have designed test cases in such a way that it is always possible. Okay, the permutation of length m is an array consisting of m distinct integers from 1 to m in arbitrary order. For example, 2 3 1 5 4 is a permutation, but 1 2 2 is not a permutation because 2 appears twice in the array, and 1 3 4 is also not a permutation because m is equal to 3 but 4 is in the array, right? So GCD of x comma y denotes the greatest common divisor of integer x comma. I think you guys know what is GCD. Even if you don't know, don't worry, I'll be telling you. So input has first line as test cases, which is t, and for every test case we have n as number of, length of the length of the permutation p, and second line has p1 p2 up till pn. It is guaranteed that the given array forms a permutation. It is guaranteed that sum of n over all test cases does not exist 20 to 10 power 5. So okay, question is lengthy but it is very easy. I'll be telling you. Let's take first example wherein we have n as 3 and array has 1 3 2, n as 3, and this is one of the permutation. So yeah, what they've said is that you have given a array of length n, which is, let's say, p, and this is one of the permutations, and it is in the form up to 1 1 2, and they are arranged like okay, let me tell you what is permutation first. So for given n, permutation is a number in the range from 1 to n, right? So whatever number you are taking, let's say n is 10, or let me take n is 4. So your array should have a number from 1 to 4, and array length should also be 4, which means if you are taking from 1 to n or 1 to 4, right? So and its length is also 4, which means all the elements from 1 till 4, it should be unique. It should be occurring only one times, and there shouldn't be something like 1 2 3 5 has occurred, right? If you do this, you don't have continuous elements. 1 2 3 you have it, but 4 you don't have. That is the thing. And even if you write like 1 to 2 where n is 3, so 2 has occurred 2 times but 3 is not there, so this is not a permutation, and this is permutation, one of the permutation. And you can write this in other way also, like 2 1 4 3, this is also one of the permutation. Okay, so what they said is they've given n is equal to 3 and one of the permutation wherein if you see n is 3, so the number in the permutation should always lie from 1 till 3. So we have 1 2 3. So this is the thing they have given, and they're asking us to display one of the permutation of q, which is from again 1 to n, in such a way that the GCD of this p of I plus q of I comma p of I plus 1 comma plus q of I plus 1 should be greater than equals to 3, that they're saying. And one more thing I just want to stress here is that this length of the array should be greater than equals to 2 and less than or equals to 10 power 5, something that's it. But this is important, like should be greater than equals to 2, because let's say when you have n as 1, so your permutation has only one element, right? This is the one of the permutation, and you can't take other permutation. Even if you take, let's say, this as one of the permutation, both are same only, and since they have asked in the question, you'll have to take the sum of these two, and whatever element adjacent elements also you'll have to take, but you don't have any adjacent elements, so at least there should be two elements. That is the thing. So I think you guys got to know. And now here, let's say your one of the permutation is 2 3 1. So if you happen to see what is sum here 3, what is sum here 6, and what is sum here 3 again. So P of I plus Q of I is basically this thing, right? P of I plus Q of I, and then the next element you'll be taking. So let's take how many pairs you are getting, I mean adjacent elements, these two and these two. So if you happen to choose GCD of 3 comma 6, these two, I mean sum of these two, so its GCD is 3, which is greater than equals to is true, right? So if it is true, that is fine. And now, okay, if you take now GCD of this thing, GCD of 6 comma 3 should be greater than equals to 3, and GCD is 3 again here, greater than equals to 3. If you don't know what is GCD, let me tell you for a minute. So GCD is basically common greatest common divisor. So whatever element you are taking, let's say 3 you are taking, in school days we used to do, you want to divide it by 2, you can't divide it by 2, so take the next element 3. So 3 ones are 3, 3 ones are 3. So 1 you have got. So this 3 you can write in this way, 3 into 1, this you can write it. And you have 6 here. So if you happen to choose 6, so you can divide 6 by 2, 2 3s are 6, and 3 1s are 3, right? So 6 you can write it as 2 into 3. If you see in this, what is the common element? Common element is this, right? Both. So this is GCD. GCD is basically 3 here. That's why I was telling you GCD is 3. So GCD 3 here meaning is that this 3 can divide both A and B. Here A is basically 3, B is basically 6. So yeah, this is about GCD. I think you guys know, but just to refresh, I told you. Okay, this is one of the possible arrangement wherein GCD is greater than equal to 3, and one more arrangement. What if you know sum of n natural numbers, sum of n natural number will be 1 plus 2 plus 3 up to so on till n, right? So if you know how to derive the formula of the sum of n natural number, you can take one more combination. So what I'm trying to say is that whatever element is there, let's say 1 2 3 is one of the arrangement, right? So in order to uh, find the one of the other arrangement, that you take in decreasing order, these are arrangement, right? So now you add it. So 4 elements are getting like 4 4 4. So if you and one more thing, I'm saying like Sn whatever you are taking, so you can take this also. Sn is equal to reverse this combinations, I mean arrangement, n minus 1 plus n minus 2 plus up to so on till 1, right? You can write this way, n minus 1 n, so you can write 2 plus 1 this way. So if you add now, this will be 2 times Sn is equal to, this will be n plus 1 plus of, again this will be 2 2 plus n minus n is n minus n plus 1, n plus 1 up to so on till n plus 1. So if you see you have a pair of this thing, right? This will give you n plus 1, n minus 2 plus 3 is n plus 1 only. So how many n plus 1 you will be having? So it is starting from 1 till n. So n plus 1 you will be having. So you can write it as 2 times s of n is equal to n into n plus 1, right? So in the same way, so if you have a number, it's a permutation of n is basically, in the array you will be having number from 1 to n, right? And which is like natural number from 1 to n. So if you have that number, so you can reverse the mirror that numbers. So basically mirroring means this is lowest, and for the lowest you will take the highest, and this is second lowest, you will take the second highest, and this is third highest, you will take the third lowest. This element you are taking, and whenever you do sum, that sum will be n plus 1. In this n is 3, so 3 plus 1 is 4, so that will be 4. And if you want to take GCD of adjacent elements, that will be n plus 1, right? Your GCD will be n plus 1. Always your GCD will be n plus 1. And as said in the question, your n is greater than equals to 2, which means your GCD will be greater than equals to, if you write 2 here, so it will be greater than equals to 3. So this will be satisfied. So valid arrangement, if you can see, one more valid arrangement would be, so whenever you have one, this is lowest, so take the highest element, which is 3. This is highest, take lowest, and 2 as it is, right? This is also one of the valid arrangement wherein your GCD will be greater than equals to 3. So I think you guys are getting. So how do you find this element, right? In order to find this element, like q of I, if you want to find the element at q of I, that will be given by n minus p of I plus 1. So n is basically 3, and 3 minus p of I plus 1. So it's like you're making cube, right? So p is 1. If you substitute 1 here, 1 minus 1 plus 1 is 0, and 3. So you have got 3 here. If you want to find the q of I for 3, so you substitute here 3 plus 3 minus 3 get cancelled, you're getting 1, so which is 1. And in a similar way 2 you can calculate. So basically the problems boiled down to the formula q of I is equals to n minus p of I plus 1. So this will boil down to that. I think the increasing order and decreasing order like made sense. So let's take one more example, 5 1 2 4 3. So we have is 5 1 2 4 3, wherein n is 5, right? And this is one of the permutation. So if you see in permutation, you have number from 1 till 5. So 1 2 3 4 5 you have, right? Now if you want to find the combination, so again you take a 1 2 3 4 5, and you take in reverse order 5 4 3 2 1, right? So wherever you have 1, there you insert 5, right? For 2 you insert 4, for 3 you insert 3, for 4 you insert 2, and for 5 you insert 1. So if you now add these values, that will be always n plus 1, which is 6, right? 6. So if you happen to choose GCD of pair elements, that will be 6 only, right? And which is greater than equals to 3. And how do you on the go for a given pair, how do you find this value? So as I said, that will be given by q of I is equals to n minus p of I plus 1. Yeah, this was it about the problem. So let's try to code it up. I don't know if this video also having correct audio or not, because when I'm shooting I will not be aware of that. Yeah, let me code it up in front of you. So we have test cases. So test cases I have taken care of at this position in the main function, and for every test case we have n. So for every test case I'm calling a solve function. I have n, and we have n elements for which we have to find the qi element, right? So let me take int p. For int is equal to 0, I less than n, I plus plus. I'll be taking this p, I mean for every pi element I'll be taking in p, and I need to display on, I will not be taking a vector, or I'll not be storing those elements. On the go, basically I know the formula n minus p of I plus 1. So on the go I'll be displaying those values. So that will be n minus p plus 1. And the answer should be space separated. At the end you'll have to display the next answer in the next line. next answer in the next line. So end L. Let's try to submit it. I mean run it. So they're expecting some order, but that is not in correct order. Let's try to, I mean, they're expecting in some other order. We are doing in some other order, which is also valid. So let's try to submit and see if it is running fine or not. Sorry. So its name is fun permutation. Let's try to submit it. So yeah, again it is saying you have submitted exactly the same code before, so that is the reason it is not getting submitted. So I have submitted it here. So yeah, if you happen to write this code, so this will get accepted. So yeah, thank you guys for watching the video.